Hello everyone. Today's lesson is going to be on composition of functions, which is another way that you can combine different types of functions together aside from the addition, subtraction, multiplication, division we saw in the previous couple of lessons. Okay, so before we formally define what this is, we're going to do a couple of examples to give a flavor for what's going on here. So this first one is something you would have done in the past. So I'm given a function f of x, and I want to determine what does f of a plus 2 look like. So all we really have to do, right, is substitute a plus 2 wherever we see x in the original function. So if I have f of a plus 2, that's going to equal a plus 2 all squared minus 2 times a plus 2 plus 3. And now it's just going to be a matter of doing some expanding and tidying this up. So a plus 2 squared means I have a plus 2 times a plus 2. I can do all my expanding, right? So my first pair of brackets, I'm going to end up with an a squared plus 4a plus 4. And my next pair of brackets, I get minus 2a minus 4, and then plus 3. So I am left with a squared plus 2a plus 3. Okay, so now example 2. Given that same function, f of x is x squared minus 2x plus 3, and g of x is x plus 2, determine f of g of x. Now that might look a little weird, okay, substituting a function inside of a function, but we're going to follow the same steps, right? So to do f of g of x, right, what does that mean? Well, it means everywhere I see x, right, I would substitute it with g of x. Okay. Now, because it'll be a little bit messy, I'm going to rewrite this first, right? G of x is just x plus 2. So right, I'm going to substitute my function g of x plus 2, wherever I see x. Okay. So that's going to be x plus 2 squared minus 2 x plus 2, and then plus 3. Now, of course, we really just did this with a plus 2, right? The exact same thing, just with a different variable. So if I work this through, I already know what it's going to come out to. It's going to be x squared plus 2x plus 3, like we had above. So this is kind of our last, at least in this course, way of combining functions, right? It's not like adding or subtracting them, it's substituting one function into another function. Okay, so that process is called composition, right? The process of substituting functions into other functions is called the composition of functions. And like with addition and subtraction, the other operations, right, we have a notation for this. Okay, so given two functions, f and g of x, the composite function okay, is f of g of x. Okay, we note this with just a little open circle, okay, to show the composition, or you could just write the f of g of x. Okay. Okay, and again, that just means we create a function by substituting function g into f, and then if possible, tidying that up. Okay. Again, that's just a little open circle. It's not an O. It doesn't say fog in here. Okay, it's just a little open dot. Okay, so again, just to get a handle on the notation. We'll do a couple more examples to kind of show how that works. So we're going to take a little step back here and go to some point tables. Right? If my function f is these 3 points, 4, 1, 3, 2, and 2, 3, then my function g is 1, 5, 2, 4, and 4, 2, we're going to determine a few things. So here's our first one. We're going to figure out what is f of g of 4. So the easiest way to see what's going on is, again, just to switch notations, right? That f of g of 4 means I figure out what is f of g of 4. Okay, so I start with the inside, right? What is g of 4? Okay, so I go to my point table, right? When x is 4, y is equal to 2. So g of 4 is equal to 2. So this now becomes f of 2. Okay, now I calculate f of 2. I go to my other table. When I input 2, my output is 3. Okay, so this whole thing is equal to 3. So f of g of 4 is equal to 3. Okay, for next one, g of f of 4. So same idea. This is g of f of 4. Okay, what's f of 4? Okay, when I have 4 for x, I get 1. Okay, so f of 4 is equal to 1, pardon me. So that becomes g of 1. Okay, what's g of 1? G of 1 is equal to 5. So I get 5. Okay, last but not least, we're going to create the point table for f of g of x. So what does the entire function look like? Okay, so in order to do this, we're basically going to start with the domain of g. Okay, so what are all the possible values for g there? Right, well, g, I can start with a 1 or 2 or 4. So these are the possible points. Okay, so let's write those out. Okay, let's start with the 1. And let's see what happens. If I tried to do f of g of 1, okay, I would go up first to 1, right? When I input 1 into g, okay, I would get 5. And then take the 5 and try to use that in f. Okay, but there is no 5 up here. So that point's actually not going to work. Okay, and again, I'll write that again on the side just to show what I mean. Right? I'm trying to figure out what is f of g of 1. Okay, g of 1 is 5. Okay, but there is no f of 5. Okay, because there's no 5 in my input table for f. Okay, so I can't actually use that point. So we'll take that back out. Okay, our next thing in the domain is 2. So let's try that. Okay, so when I plug in 2 for g, I would get 4. And then I look for 4 in f, and it becomes 1. So the point 2, 1 is in f of g of x. And then finally, for my last input value, okay, for 4, well, we did that already. We did f of g of 4 up here. So 4 and 3. Okay, so my new function, f of g of x, actually has fewer points than the original because one of the inputs, right, one of the values for g didn't work out in f. Okay, so that's like a side point here, that the domain, okay, the domain of f of g, okay, can't be any bigger than the domain of g, right, but it could be smaller. Okay, so our domain is smaller. see with some of the functions, like let's say if we were combining, logarithm with something, right? It has a restricted domain. So if we were combining with another function, then those restrictions will apply to the new function as well. Okay, for our last example, okay, we're going to do this process one more time. So given that f of x is 1 minus x squared, and g of x is equal to cosine of x, we're going to determine equations for f of g and g of f. Okay, so let's start with f of g of x. So once again, same idea. This means I'm going to do f of g of x. So that is f of, my function g is cosine of x. So now I replace, right, when I look at f of x, and I replace x with cosine, so this becomes 1 minus cosine of x squared. Now, we don't normally write it that way. This is 1 minus cos squared x. Okay, and digging back into our tricks from trigonometry, that would be equal to sine squared x. Okay, so my function f of g of x is actually sine squared x. Okay, now let's do the same thing the other way. So I wanted to do g of f of x. So that means I'm going to take f of x and substitute that into g. So my function f is 1 minus x squared. And so I've got cosine of 1 minus x squared. Okay, so quick side note, there's nothing I can really do to simplify this anymore. I mean, I suppose we could break it apart with subtraction formula, but that would probably just make it a little bit messier in some ways. Okay, although, while we're here, why not? Let's try that out and see what happens. So this would be cosine of 1 cos of x squared plus sine of 1 sine of x squared. I should put some brackets in there. Remind myself it's the x that's being squared. So I suppose we could tidy this up. We could look up what's cosine of 1 on our calculator. It's not going to be a nice value, but that is an alternate form for that expression. Okay, but for our purposes, this is really simple enough. Okay. For both of these functions, right, we don't really have any experience graphing it, so I wouldn't ask you to graph one of these composite functions by hand. Okay, you'd want to do it with technology. Okay, so for example, let's do that last one just to see what it looks like. Okay, so here's y equals cosine of x, just for review. Okay, and now we'll change the argument. This is cosine of 1 minus x squared. Okay, yeah, it's got a very different appearance than regular cosine does. Okay, again, what's also nice about Desmos is that we could probably just list the functions out, right? F of x was 1 minus x squared, so this parabola. Okay, g of x was cos sine of x. Okay, and now that function I just did was g of f of x. Okay, and there's the picture right there. Okay, similarly, I could graph f of g of x, and we can see what it looks like too. Okay, and compares to totally different things than what happened there in the conversations. So that's it for the lesson. Okay, just about the technique part. So there's some practice work that you can work on, okay? Or of course you could be working on the assignment that you got earlier in the week. Thanks for watching, and I'll see you next time.